YouTube channel. In this video lecture, I'm going to answer questions from sample paper number 6, which you will find in the last pages of RK Bali navigation book. So let's begin. Question number 71. Simple. Aircraft is attempting to home to a VOR station. Home means it is flying inbound towards a VOR station on radial 064. The CDI shows 4 dots fly right with a 2 indication. At the same time, DME shows a range of 45 miles. Where is aircraft in relation to the required track? So here is your VOR DME station. Okay, this is your VOR DME station. This is your north datum and radial 064. Let's say this is your radial 064. So the reciprocal of that radial becomes 064 plus 180, 244. Now you are flying inbound towards a VOR on radial 064. So that means you are situated on radial 064 and you are flying inbound. Okay, you are flying inbound. Okay, towards the VOR DME station. Now ideally you should be located on radial 064 because that is the information that you have put in the OBS selector of your aircraft. You have put radial 244 and that's why you have gotten a 2 indication. Now if this aircraft maintains this radial 064 inbound, the CDI needle of this OBS selector will remain in the center, position. But as given in the question, the CDI is showing 4 dots fly right indication. 4 dots fly right indication. That means, let's say this is your OBS selector. Okay, so if this is the center position of the OBS selector, the CDI is showing 4 dots fly right. So somewhere here, like that. 4 dots to the fly right position. Now CDI needle always gives you the solution. It always gives you the solution. So what is the problem? The problem is that aircraft has deviated from its correct track. So over here in this case the correct track is track 244 inbound. Okay, but aircraft is not situated on that track correctly. It has deviated somewhere to the left hand side. Now going inbound, this becomes your left hand side, this becomes your right hand side. The perspective changes. Going outbound, this will be your left hand side, this will be your right hand side. So in this case, if the CDI is giving you a solution of fly right, whatever dots, 2 dots right, 4 dots right, whatever that is, that means aircraft has deviated somewhere to the left hand side. So I will draw this diagram again. This is your VOR station, VOR DME station, let's say. And this is your original track, 064 inbound, 244 here. But aircraft, instead of being on that track, is somewhere to the left hand side of it. That means somewhere here. It is somewhere on the left hand side of it. Okay. And since when it is onto the left hand side of it, that means it will be situated on some different radial now. Okay. It will be situated on some different radial. So 4 dots fly right indication. Okay. Now whenever you are dealing with VOR sums, 1 dot is equal to 2 degrees. 1 dot equals 2 degrees. So 4 dots will be equal to 8 degree angular deviation. 8 degree angular deviation. Right? So that means aircraft is deviated 8 degrees to the left hand side. 8 degrees to the left hand side. Okay, so instead of being here on this track, it is somewhere on this track, and that the name of that track or the number of that track will be track 064 plus 8 degree, because this track is to the right hand side of 064. So that is 064 plus 8 is 072. That means aircraft is situated on track or radial 072 and it is trying to fly inbound. Now we have to we have found out that aircraft has deviated 8 degrees to the left hand side. Okay, going inbound, aircraft has deviated to the 8-degree left hand side. We have found out angular deviation. Now the question has asked us to find out, the question has asked us to find out distance deviation, okay, in terms of nautical miles. So I'm going to draw another diagram here. This is your VOR DME station. Aircraft, aircraft should be on radial 064, but it is on radial 072 somewhere here. And the distance that it is away from this VOR DME station is 45 nautical miles. So let's draw that 45 nautical miles. Let's complete this triangle. This is the triangle, and the deviation, angular deviation, is 8 degrees. Now we have to find out this distance of track. Okay, so let's apply 1 in 60 rule formula. Track error, that is distance of track, distance gone, multiply by 60. So track error is 8 degree. Distance of track we have to find out. Distance gone is 45, multiply by 60. So distance of track is 8 into 45 divided by 60. 8 into 45 divided by 60 is 6 nautical miles. So that means aircraft has deviated 6 nautical mile to the left hand side, or 8 degree to the left hand side. So correct answer is 6 nautical mile to the left of track, because going inbound, this is your left hand side, this is your right hand side. Okay, so that is your answer. Question 72. Which of the following is a horizontal axis tide gyro? So remember, artificial horizon is vertical axis, earth gyro, turn and slip indicator is horizontal axis, rate gyro, DGI is horizontal axis, tide gyro. So correct option is option Charlie. Next, question 73. In what way does IRS, Inertial Reference System, differ from Inertial Navigation System? So the correct answer here is inertial reference system does not use any mechanical motor or any mechanical object to spin itself. All it uses is ring laser gyro. So so it has an advantage that it has shorter spin up time compared to inertial navigation system, but it suffers from laser lock. So option A is the correct answer. It has shorter spin up time. It will start spinning early and it will complete that process earlier than inertial navigation system. But one disadvantage is that it will suffer from laser lock. And the solution to this laser lock is it has something called Bither motor. Okay, so remember that also. Next, question 74. Flight level is 330. Temperature is minus 50 degrees Celsius. Rectified airspeed or calibrated airspeed is 310 knots. What is Mach number? Now, Mach number of your aircraft is equal to true airspeed of your aircraft divided by local speed of sound. Now, you can do this sum using CX3 as well. I will show you both the ways. Local speed of sound is nothing but 39.17 square root of temperature in kelvins. Now we have flight level 330. ISA temperature at flight level 330 must be 15 degrees Celsius minus 2 into 33,000 feet. So 15 minus 66 is minus 51 degrees Celsius. Outside air temperature given here is current temperature or ambient temperature is minus 50 degrees Celsius. So let's find out true airspeed first. True airspeed is, go in the airspeed option, substitute the values. Outside air temperature is in Fahrenheit currently. Convert that, press the convert unit, and outside temperature is minus 50. So 50, then press the plus minus button in order to get minus 50. Calibrated airspeed, which is 310. Ratio altitude 33,000 feet. So now you have gotten a task of 503 knots. You have a task of 503 knots. And you have gotten a Mach number of, as you can see here directly, Mach number 0.864. So of all the three options here, the closest is option Bravo, 0.864 or 0.87. Now I will show you how to calculate this sum using mathematical formula. Local speed of sound. First, let's find local speed of sound, which is 39.17 square root of temperature in Kelvin. What is the outside temperature? It is minus 50 degrees Celsius. In Kelvins, it will be 273 minus 50. So 273 minus 50 is 223. So square root of 223. So 39.17 square root of 223 is 14.9 multiplied by 15. So into 39.17. 584.9 or closest 585 knots. Now let's substitute that here. Local speed of sound is 585 knots. So Mach number will be true airspeed divided by local speed of sound 585. So 503 divided by 585 amounts to 0.859 or something. So 0.859 is 0.86. So the closest option is Bravo again. Okay, so this is how you do it. Question 75. During a compass swing, the values of coefficients are A option A is plus 3 degree, Bravo is plus 2 degree, Charlie is minus 10 degree. What will be the expected deviation on a heading of 145 in southern hemisphere? So we are going to use the formula given in the magnetism chapter. T equals to A plus B into sine theta, where theta is your heading, C into cos theta, where cos theta is your heading. Now A is plus 3, B is plus 2, C is minus 10, and it is southern hemisphere. Okay, so in southern hemisphere, coefficient B sign is reversed. It's given B plus 2 becomes B minus 2 in the southern hemisphere. Okay, so let's substitute the values. A is plus 3, B is minus 2, sine theta, sine heading is 145, C is minus 10, cos 145. So plus 3 plus minus minus 2 multiplied by sine 145, 1.147 something. Again minus cos 145 multiplied by 10, 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 . 1.147 is minus 8.19er. So minus 8.2. So minus minus plus. So 8.2. So 8.2 plus 3, 11.2 minus 1.1 is 10.1, is 10.1. So the closest option here is 10.1 is option Charlie 9.3. Okay, 9.3 westerly expected deviation in southern hemisphere. So option Charlie. Next, question number 76. On a Mercator chart, if the scale at 30° north is so and so, what will be the scale at 40° north? So this will be a two-step process. Step 1 will be scale at a particular latitude equals to scale at equator multiplied by cos of that latitude multiplied by cos of that latitude. So now scale at equator here is the joining link between these two different latitudes given in the question. Okay, so correction, it is not scale at latitude, it is scale at, I will erase this, it is scale at equator, scale at equator equals to scale at a particular latitude multiplied by cos of that particular latitude. So here they have given us information of scale at 30° north. So let's use that. So scale at equator will be equal to scale at 30° north latitude, that is equal to 1 divided by 35 lakhs. So 1, correct, multiply by cos 30. Okay, so let's do it. So cos 30 is 0.86 divided by 35. Now in order to find scale at equator, divide numerator and denominator by 0.86. So 35 lakh divided by 0.86 is equal to 1 divided by 4069767. This is the scale at equator. Okay. Now we will use this scale at equator in order to find scale at 40° north latitude. So scale at, same formula, say scale at equator equals to scale at a particular latitude multiplied by cos of that latitude. So here we have to find out scale at 40 north, that will be equal to scale at equator divided by cos of latitude. So scale at equator is 1 divided by 4069767 multiplied by cos of 40. So cos 40 is 0.76. Okay, multiply that by 4069767. So that is equal to 1 divided by 3117622. So 300,000 lakh. So 31 lakh something. So the closest option here is Bravo, which is 30 lakhs 99,250. And here we have 31 lakh. So we can select option Bravo. So remember, step 1 is scale at equator equals to scale at a particular latitude into cos of that latitude. With this we find out scale at equator. With scale of at equator we can find out scale at any other latitude on the earth. So it's a two-step process. Question number 77. Aircraft is homing to a VOR station. Drift is 10 degrees starboard. Okay. Variation at VOR is given. Variation at aircraft location is also given. What is the initial heading to be maintained? To maintain a radial of 274. So let's draw this. This is your VOR station. Say, okay, this is your VOR station, and you are homing inbound. You are flying inbound to this VOR station. Radial 274. Radial 274. Now the reciprocal of radial 274 is radial 094. Okay. Variation at VOR station is 50° west. Variation 50 west. And always whenever you solve VOR sums, you are going to use the variation at VOR, not aircraft. For NDB sums, you are going to make use of variation at aircraft location. So this is the radial 274. Okay. And drift is 10 degrees starboard. Drift is 10 degree starboard. With 10 degrees starboard drift, heading is less than track. Now what is the inbound track? We are flying inbound towards this VOR station. Correct? We are flying inbound. Flying inbound, our track should be 094. So I'm writing it here. Track is 094. Heading should be less than track. So heading will be 094 minus 10, 084. 084. Okay. So your aircraft will be pointing something like this. Little bit to the 084 direction. Heading 084. Track inbound track 094. Heading of aircraft 084. Give the initial heading to maintain a radial of 274. So the correct answer will be Bravo 084 magnetic. Okay, because drift is 10 degrees starboard, means winds are coming from the left hand side. The winds are coming from the left hand side, and therefore you're pointing your aircraft into the wind. Next. Now here in this particular question, we need not apply variation. Variation information is given, but that is useless because already all radials will be magnetic in direction unless specified in the question. And whatever you obtain, whatever heading you obtain from this source will also automatically be magnetic in direction. So heading is 084. 78. Aircraft heading is given. ADF indication is 345 relative. So heading and relative bearing is given. Make 45-degree intercept of 355-degree track outbound. What shall be the heading to intercept and ADF indication at the time of intercept? Okay. So with the information of heading and relative bearing, you can find out step 1, track of your aircraft. So track to the station is equal to the heading of your aircraft plus relative bearing. So currently heading of your aircraft is 170-degree magnetic. Relative bearing is 345 degrees. So 170 plus 345, 515 minus 360 is 155. That means QDM, magnetic bearing to the station, is 155 degree. So let's say this is your NDB station. The reciprocal of 155 is 335. That means your aircraft is currently on, let's call this radial 335. It is not radial, but still for understanding. And this track is 155. So aircraft is flying inbound towards the NDB station. on a track of 155 like this. Okay, like this. Okay, its position is like this. But if I have to draw an accurate diagram, I will draw something like this. Position 335, heading is 170, which is more than 155. So this aircraft will point somewhat like this towards the direction or heading of 170. So heading is 170. Nevertheless, the track of your aircraft is 155. Now ATC has asked you to intercept 355-degree track outbound. So this is your track 355-degree outbound. So that means from this present position, you are expected to make a turn to the right hand side, correction, to the left hand side, intercept this track, and then fly along this track outbound. The angle given to you is, interception angle given to you is 45 degrees. Okay. The interception angle is given 45 degree. Normally we use this angle only. So we have to find out the new heading that aircraft will have to fly. It will have to change its heading from 170 to a heading which is less than 170 to intercept that track like this. Okay, over here. So what will be the new heading? New heading will be equal to new track plus intercept angle. What is the new track? 355. Angle given is 45 degree. So 355 plus 45 is 400 minus 360 is 040. That means the new heading of your aircraft will be 040. So I will draw it here. This is the station here. This is the track 335 outbound. This is the track, let's say 355 outbound. So your aircraft will have to change its current heading 170, like this, to a new heading of 040 like this, in order to intercept track 355 at an angle, at interception angle of 45 degrees. Okay, so new heading will be 040. And now next part of the question, find out the new ADF reading or the new ADF indication or new relative bearing indication at the time of intercept. That means what will be the relative bearing the moment you intercept or you cross this track P55, the moment you cross it. So currently relative bearing of your aircraft is 345. Now the moment your aircraft is positioned on track 355, what will be the relative bearing? So relative bearing is magnetic bearing to the station minus magnetic heading. So when you are positioned on radial or track 355 outbound, what will be the track inbound? Track inbound will be reciprocal of 355. Reciprocal of 355 is 175. Reciprocal of 355 is track 175. That means from this position, if you want to go outbound from the NDB station, you can fly a track of 355. If you choose to come inbound, you will fly a track of 175 inbound. So I'm going to substitute 175 here. Magnetic heading of your aircraft. What is the new heading? What was the new heading here? It was 040. So 175 minus 040 is 135. So correct option is option Bravo. Next, question 79. If PNR is calculated to be 880 nautical mile with 10,000 fuel, what will be the new distance to PNR if the fuel is 11,000 kg, 1,000 kilograms more, all other factors being constant or equal? So this is one property of PNR, that percentage increase in fuel. Remember, this question is often asked in ATPL also. Percentage increase in fuel will be equal to that much percentage increase in PNR distance. That much increase in PNR distance. So let's solve this now. Original or initial fuel on board 10,000. New or final fuel on board 11,000. So percentage increase or the increment is equal to new fuel on board minus old fuel on board divided by old fuel on board multiplied by 100. So 11,000 minus 10,000 by 10,000 multiplied by 100. 11,000 minus 10,000 is 1,000 into 100 divided by 10,000. So the increment is, percentage increase is 10% increase. So next step, new PNR distance will be equal to old PNR distance plus increase. It will increase by what amount? Plus 10% of old PNR distance. Like I said, the new PNR, if fuel has increased by a certain percentage amount, the PNR distance will also increase by that much amount. So old PNR distance is 880 plus 10% of old distance, which is 10% of 880. So 880 plus 88. 880 plus 88 is 968. So new distance PNR is 968 nautical miles. 968 nautical miles. Simple. Last, the principal advantage of a gyromagnetic compass, slaved gyro compass, is that it does not have to be aligned with the north. It has to be. It does not recess. It does. So correct option is option Charlie. It combines the north-seeking ability of a normal magnetic compass with the stability provided by DGI, directional indicator. So that is the principal advantage. So option Charlie. So this concludes our lecture. I hope you have understood all the 10 questions that I did in this video lecture. There were some questions based on NDB, VOR, PNR, very important questions. So do this, practice these questions multiple times without taking any help or looking for answers or explanations. Do it on your own. This will boost your confidence. All the best. Share this video with your friends, please. Hit the like button and subscribe if you haven't yet. In my next lecture, I will solve the remaining questions. So don't miss that. See you.